Right, we've studied arc length with rectangular equations or just normal functions, and we've studied arc length when you have a parametric equation. It's now time to study arc length of a polar curve. So at the end of this lesson, you'll be able to find the arc length of a polar curve. All right, so we've got this formula going here. Again, you'll notice let f be a function whose derivative is continuous on an interval from theta from these two values. I believe it's alpha and beta, but I'm not exactly sure. The length of the graph r equals f of theta from theta equals alpha to theta equals beta is equal to this formula. So you'll notice pretty similar to the other arc length formulas that we've done. Notice this one goes from a certain angle to another angle of the square root of r squared plus dr d theta squared. That just really is r prime. So that's basically it. And we are ready to do an example to show you how to do arc length. Okay, find the arc length, of the arc from theta equals 0 to theta equals 2 pi for the curve r equals 2 minus 2 cosine theta. The first thing that I'm going to do before I do anything else is let's find r prime. The derivative of 2 is nothing, and the derivative of negative 2 cosine theta will be positive 2 sine theta. So now to get that arc length, we are going to, they call it little s, I like to call it L because L stands for length, and that just makes more sense to me. Okay, we are going to go from 0 to 2 pi because that's what they told me, and then it's going to be the square root of r squared, so it'll be 2 minus 2 cosine theta squared, and then plus the derivative squared. Our derivative is 2 sine theta squared, and of course it will be d theta. And then from here we have it set up, so we're going to let Math 9 do the work for us, and the arc length will equal 16. So hopefully now you know how to find the arc length of a polar curve.